Okay, airport operations. We've covered this in the concept course, but we do repeat it because the FAA considers this a pretty important issue, and in fact it is. We will sometimes be operating in the areas nearby airports by necessity. It just happens from time to time. We're going to sort of focus on uncontrolled airports here. Some of the same concepts apply to a controlled airport, but we'll mostly focus on that. The regulations, Part 107.41, no person may operate a small unmanned aircraft in these classes of controlled airspace, Class B, C, or D, or within the lateral boundaries of the surface area of Class E airspace designated for an airport, unless that person has prior authorization. So we should get authorization at these controlled airspace. However, in 107.43, it says operate in vicinity of airports altogether, which includes controlled and uncontrolled. No person may operate a small unmanned aircraft in a manner that interferes with the operation and traffic patterns at any airport, heliport, or seaplane base. Heliports, remember, sometimes they'll be at a hospital, so we have to keep that in mind. It may not be, it'll indicate a hospital, but, so we want to be aware of that anyway. And then Part 107.37 down here, operation aircraft right-of-way rules. Each unmanned aircraft must yield the right-of-way to all aircraft, all airborne vehicles, and launch and re-entry vehicles as well. Yielding the right-of-way means that the small unmanned aircraft must give way to the aircraft or vehicle and may not pass over, under, or ahead of it unless well clear. And of course, B, no person may operate a small unmanned aircraft so close to another aircraft as to create collision hazard. Why are these rules there? It seems obvious to me. We do present a hazard. My personal rule is don't scare manned aircraft pilots, because you know what happens then. Then they call the FAA and they complain, and then the FAA either tries to find you, which is no problem. I don't mind them contacting me, but the problem is that if it keeps happening, the FAA is going to cause, we're going to have to pass more laws or get more laws passed to restrict our freedoms to fly, and that's not a good thing. So we don't want to scare manned aircraft pilots. So let's stay clear of it. Let's be aware of that. But let's not be so paranoid that we never operate around some airports, because there are rules and ways to ameliorate the risk involved. Okay? So those are the rules anyway. Here's the, okay, so let's look at the sectional chart. The sectional chart has some stuff specifically about airports, and we've talked about it before, but you see over here the magenta colorings, those are uncontrolled, and then these blue ones are controlled airports. So we know if it's blue airport on your sectional chart, we must obtain permission from the air traffic controllers that are in charge of that airspace. But if it's magenta, or some people want to call that purple, fine, that's an uncontrolled airport, and we may fly near there. However, we may not cause any disruption to the air traffic going in and out of that airport, manned aircraft going in and out of the aircraft, or present any kind of hazard to them at all. We don't want to scare them. Okay? There's other little things down here, seaports and other designations too of interest. Controlled airspace, just to review real quick, blue, Class B over here. It's the blue shaded line around airports. We need permission to go. Class C, need permission. Class D, need permission. Class E, surface is dashed, and then the shaded lines is 700 feet or 1,200 feet. Okay, so we've already talked about that before. If we haven't talked about it before, we will in the future talk about it. Basically, you look at the sectional charts, you see the color of the airport, and you know whether or not you need to contact ATC or not. Okay, here's an example of a local airport. This is Griffin Spalding County Airport. On the chart, it's got magenta. Okay, oh great. There's no permission involved, except some drone manufacturers want you to agree to be careful around there, so you have to check off a mark or whatever. But and then we have two sources of information. We have the sectional chart, which gives you the name of the airport here and the elevation above sea level of the airport, and it also gives you the number here, 123.075, that gives you the C here. C is Common Traffic Advisory. Common Traffic Advisory Frequency. That's the number. In this case, sometimes it'll spell it out, sometimes it'll just have a C. You tune that to your radio, 123.075, and you can listen to the pilots that are self-announcing in and out of this airport or operating in the area of the airport, telling other pilots where they are. Air traffic controllers, the FAA and manned aircraft system doesn't really encourage drone pilots picking up a radio and calling. Actually, we have a transceiver that can go on these frequencies with the ability to transmit, but you need a license for that, FCC license to do that. Now I do because I'm a manned aircraft pilot, so I could, but it doesn't really, not that helpful to be telling manned aircraft where you are. Now, that may be something in the waiver. If you do apply for a waiver to operate near an airport, it may be required that you do communicate. But normally, they just want you to listen. But it's important to know what's going on so we can listen and be oriented. So that's the chart. Then we have the chart supplement US, which will have diagrams like this, which will tell us the actual runway number, 32 for that runway, 14. This is Griffin. And the length of the runway and the orientation of it and all that. And we'll talk about runway numbers in a second. So there's two different sources that we can gain information about a particular airport. The chart supplement US gives us, also has another part of this page I'm not showing you that gives you the frequencies. These numbers will be on that chart as well. All right, so basic review again. The runway numbers are based off of their magnetic heading. So when we say runway 32, we're saying that when the airplane is sitting on the runway, he is pointing in that direction. There's an arrow. That's like an airplane. Okay, just imagine that. Okay, that's an airplane. When they're sitting on the runway for takeoff, they're pointing at a heading of 320 degrees magnetic. We drop the 0, saves paint, because we paint this on the runway so that to remind them. Or if you're flying over the airport as a manned aircraft, you can look down there and say, oh, okay, that's runway 32. That must be the right airport. So that's the orientation. That's how we name the runways, by the magnetic heading. And incidentally, you saw the way the runway looked. It was sort of like that. Well, man, my handwriting is terrible. So if you're going to land in this direction, it'd be runway 12. Man, I drew that pretty badly. 14. I'm sorry, 14. That's the runway 14 because you're pointing at runway 14. That would be the name of this runway. This runway would be 14, and this runway would be 32. Magnetic heading. Okay, so that's important because when the manned aircraft, you're listening on the radio, the FAA is assuming you're listening on the radio, and some guy says, I'm about to take off on runway 32 at Griffin Spalding Airport, you know he's here. And this is the way he's going to be going. He's taking off on 32, he'll be going that way. So if you're over here somewhere, he'd be flying over top of your head. Or if you're taking off the other way on runway 14, so you need to be aware of that. Here's what the patterns are. This is all of the reference points that pilots in traffic patterns will use, and that will help you to know where they are in relation to the runway. So you're operating near this airport somewhere. If they're using runway 14, you hear on the radio, yes, we're using runway 14. That means they take off this way. Remember, this runway here is pointing in the direction of 140 degrees. Leave the 0 off. It's runway 14. So they take off on this runway, they climb, they get up here, then they turn what they call a crosswind. That means this part in this section right in there is the crosswind leg. That section right there. Then they'll turn another left turn, left-hand patterns are normal. On the downwind leg, that's this whole section. This whole section here is called a downwind leg. Traffic patterns are normally left-hand patterns. Just assume that everybody's going to make left-hand turns. That way other pilots, manned aircraft, know where to look too. It's not just you. They're not doing this for the purpose of letting drone pilots know where they are. They're letting each other know, since there's no air traffic controller, they're letting everyone know, hey, this is where I am. You know, they're using technical language, and I'm just using vernacular just because we're in an instructional period here trying to help you understand where we're talking about. So, hey, I'm on downwind legs. So everybody, every other aircraft that's listening on that frequency knows, hey, they're somewhere in this area here, so I know where to look. And if I'm there too and they're there, then maybe they're very close to me. I better be careful. Okay, so then they come down here, make another left turn onto what they call a base leg. That's this section here. And then final approach is when they turn final or final. Normally they just say final. So those are the traffic pattern names to help us and other pilots know where they are. And of course, it all changes now. We go to a different runway. They're landing, by the way, they land into the wind, just like birds, just like we ought to as well. Here's the other way. Now we're going to use runway 32. Runway 31. Or 32, that's right. Runway 32 is this one pointing this way. So they take off and they're upwind leg, but then they turn what they call a crosswind leg, this section here. Then they turn a downwind leg here. They turn a base leg here and a final leg here, going that way to land. So what the question will come up on the FAA written test is like, they're using runway 32. If you hear somebody calling on a left downwind for runway 32, where are they? A, north of the airport. B, east of the airport. C, southwest of the airport. Well, if they're on downwind leg, they're over here. If this is north, and this is east, and this is west, and this is south, where are they? Well, they're southwest. That's what they're looking for. The written tests are not determining whether you can memorize a bunch of facts, but they're trying to see if you understand the whole concept of what they're doing in the traffic pattern. So that's what this is about. And every airport's going to be different. The runway isn't always runway 32, right? So you sort of have to skew this chart around to understand where downwinds and upwinds and all that are. So, and I get it. It's a bit of a difficult concept, but just give it some thought. So now we have to think about how we talk to each other. So we have a standard way of talking. Air traffic control, pilots talk to each other, and air traffic control talking to pilots, and pilots talking to air traffic controllers. We're using 1950s, 1940s, actually 1930s technology. It's called a transceiver. It's like a radio that you talk into a microphone that interprets your voice into electronic signal, and it flies through the air to a receiver somewhere. Everybody uses the same frequency, so two people can talk at the same time, but they can't be understood when they're both talking at the same time. Plus there's static, and then there's sunspots, and then there's magnetic, and all kinds of stuff can happen. It's hard to understand each other sometimes. So we use standard phraseology. That's what you see in the standard phraseology as far as numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, you know, in the phonetic alphabet. Alpha, Bravo, Charlie, Hotel, etc., etc. So we use those numbers. When we talk about numbers or letters, we sound it out so it makes sense. So there's an actual pilot controlled, there's actually you can look it up. The FAA has a list of how we say the words exactly, which should suffice. But two-way communication between UAV and ATC is generally discouraged, or other pilots as well. We understand that there must be permission to go into controlled airspace. However, whether you're nearby an airport with a control tower or outside the airspace, don't have permission, it's good to know what's going on, or if we're in uncontrolled airspace, it's good to understand, definitely good to understand where everybody is there too. So we listen to that to the AT3 frequency or the Common Traffic Advisory frequency. English is the language of technology, but it's exactly 30s, 40s technology. We can talk over each other. I've already mentioned that. We also have an issue with English is the universal language of aviation. So we have people with very heavy accents trying to talk to each other over the radio. We have to try to understand them. They have to understand. So it's best to use the full number. This is an example. We're listening, and some guy's trying to tell us they're at 5,500 feet MSL. They need to be talking clearly and slowly, and they need to say every number, 5,500 feet, not 5,500 like I just said, but each syllable should be separately pronounced because we're talking over a poor medium, which is radio. Plus, there are people out there that don't speak English is not their first language, so we're helping everybody to understand what we're talking about. Here's another example, an aircraft call sign N207PS. Well, that can be interpreted many different ways, but if we say it over the radio, November 207 Papa Sierra, it makes a little more sense. It's a little easier to understand. There's a joke. Sometimes my name is not the easiest one to pronounce on the telephone. Telephone's sort of similar, except that only two people can talk, but sometimes two people talk at the same time too. But I'm talking to somebody, I'm trying to give them my credit card number or something like that. Or worse yet is my last name, so I can spell my last name. Well, D and T sounds the same. So if I say DT, I don't know how many times people put two T's or two D's at the end of my name. So I have to spell it out. Echo, Romeo, Charlie, Kilo, Hotel, Alpha, Romeo, Delta, Tango. Ah, that makes sense. Even if they don't know the phonetic alphabet, those letters work. Of course, then there's always some wise guy that read it back like, let's see, Eddie, Cadet, something, use other language, but, or they've seen too many TV programs. Anyway, that's how we talk. And believe it or not, on the written test, there will be questions asking you, what's the correct method of saying 5,500 feet MSL? Or even a call sign. What's the correct call sign? And then give you 3 choices, multiple choice. Okay, so that's the language using phraseology that is sort of standard. Don't obsess over this, but as you listen to the frequencies, the more you listen to the radios, the more you'll sort of start to catch on what they're saying. But there's standard phraseology, and then there's a standard way to start a conversation, all right? Either with ATC or manned aircraft. At about 10 miles from the airport, the scenario here is we're coming into land. We're in a manned aircraft. We're sitting in the airplane. We're flying the airplane. We already know what the frequency is, the CTAF frequency. In this case, wouldn't matter. It could be ATC. It'd be the ATC frequency. But either way, you start out saying, who in the world are you talking to? You got to talk, Griffin traffic, in this case, an uncontrolled airport on CTAF. You say, who are you? Who are you talking to? Griffin traffic. So now everybody that's flying in the area of Griffin that's listening on that radio, now, their ears perk up. Okay, this guy's talking about something to do with the airspace I'm in. Griffin traffic. Then you say, who are you? Drone number 5. Where are you? I'm a mile south of the airport. What are you doing? I'm 400 feet and below, taking some pictures or something like that. You don't have to elaborate on what you're doing, but they need to know where you are, what you're doing. I'm flying 400 feet or below, a mile south of Griffin. If you have a request, if you were talking to ATC, you might be a request. In this case, you're just informing people what you're doing. Then you got to repeat. Who are you talking to? Griffin traffic at the end of it. Nobody answers. Nobody needs to answer. You're just saying who you are, where you are, what you're doing, so that the people in Griffin area know what you're doing. Okay, so here's an example. Near an airport in Class G airspace, Mountain Hawley traffic, unmanned aircraft 1 Alpha, operating 5 nautical miles south of the airport at or below 400 feet above ground level. Taking photographs. Mountain Hawley traffic. As simple as that. Then you don't want to spend much more time talking than that. You're just blocking off a frequency and then nobody else can talk. So you just want to keep it brief, just make a statement, and then if somebody can ask you a question if they want, If you're talking air traffic control, yeah, they need to respond, but in most cases, we're not really talking about that. Again, pilot-controlled airports, manned aircraft inbound to the airport will call 10 miles out and just say the same thing. Griffin traffic, Cessna 206, Papa Golf, 10 miles west, landing on runway 14. Griffin traffic. That's the kind of thing you'll hear with a lot of static in the background and et cetera, but that's what you'll hear. Okay, well, now he's west of the airport. What does that mean? Let's just look at that for just a second. Find a pen. Okay, so we said, oh, good grief. Okay, sorry. Hang on, just give me a second here. Okay, here's the airport. I don't know why that didn't work, but okay, we said he was landing on 14. He's, okay, this is north, this is east, this is south, this is west. He's 10 miles west of the airport. Where is he? He's out here somewhere, coming into land. So you know now from what that guy just said that he's out here somewhere. He's going to come on in here and land. So you know if you're out in this area, you need to keep an eye on him. But if you're way over here, who cares? Just like when they're inbound to the airport, before they're going to take off, some guy taxis out and he's on the ground. He taxis out here. He goes out here. Okay, I'm going to take it off on runway 14. And you know he's going this way. He's taking off. He's climbing up and all that stuff. If you're over in this area now, you need to be concerned because he may be going to head your way. So these are things that are helpful, knowing which direction they're going, where they are. So before departing an airport, manned aircraft will announce their ground position and flight intentions on that same frequency. So the big deal, of course, is the guy that's about to take off wants to know where this guy is out here that's coming into land because they don't want to both be on the runway at the same time. Not good. Not good at all. All right, so here's the compass rose, just for a reminder again, east, north. I mean, this is the basic situational awareness, knowing where the compass points are. Charts are always north is at the top, south is at the bottom, east is on the right side, and west is on the left side. So it gives you some idea of an orientation with that. Here is a picture. Oh, manned aircraft use compass coordinates for position reports. That's important. They will use those compass points for position reports in relation to some geographical place. And that's why they state who they're talking to. So when they say they're 10 miles west of Griffin Airport, we know it's that way. If they say they're 10 miles east, then we know it's that way. But also they can use this as the direction that they're flying in too. If they say they're 10 miles east, flying east, that means they're over here somewhere going in that direction because that's where east is. So they're 10 miles east going away from the airport. So they use those directions in different ways, either in relation to a geographical location or in relation to where they're heading, airplane is pointing to and which direction they're going in. It's helpful to remember that. I've got a few more examples here. Yeah, that's the same chart we looked at before. There are methods for them to enter a traffic pattern, standard methods. If you're a manned aircraft, this is super important. So that people just can't just fly in just at any old angle was a predictable way to do it. So this is how you enter the traffic pattern. You sort of head in at about a 45 degrees to the downwind leg normally. And when you leave the traffic pattern, it's either that way or this way. You go out that way at a 45-degree angle, or you go straight out. I was not aware. Here's a runway here. So if we were in class, I'd say, what does the magenta coloring mean? Where is this? Norwich, I'm not sure where this is in the program. But anyway, what does the magenta color mean when you see an airport symbol with magenta coloring? Yes, that's right. Uncontrolled. Uncontrolled, so we don't look for an airport, we don't look for a tower frequency or a GZ, we look for a CTAF frequency, which is 22.8. CTAF, that's the C. CTAF 122.8. That's a common traffic advisory frequency. So that's the number, that's the frequency we want to tune into our radio to listen to see what's going on here. You pretty much from the symbol here and the fact that the top of the chart is north and this is east and this is south and this is west, we can almost presume that that runway is runway 36 going that way. So there's a runway that goes, there's a runway, there's 36, and then there's runway 18 going that way. So if somebody says they're on left downwind for runway 36, that means they're landing this way. So let's see, left turn, left turn, left turn, left turn. This is downwind, so he's over here somewhere. There's your little airplane going that way. If he's crosswind, he'd be here. If he's base leg, he'd be here. Final approach here. Same runway over here. This is 36, and this is 18. All right, if they say they're on left downwind for runway 18, I mean for runway 36. No, runway 18. I was right the first time. Sorry. So they're taking off this way. Which way is left? Which way left would be this way, wouldn't it? So that's crosswind. They come out here, then they turn downwind. Oh, I got to erase that because that's no good. That W is just going to confuse the heck out of everybody. Okay, so they're downwind. Oh, I changed colors. How about that? Ooh. So, yeah, cool. Let's see if I can get it. There it is. That's crosswind. This is downwind. This is base. So if they say they're left downwind for runway 18, they're over here to the east of the airport. So runway numbers are important. Knowing that left-hand patterns are normal, that's important. Knowing whether or not the airport may have a non-standard pattern, this is standard traffic patterns. So it's always left-hand turns. And this would apply whether it's controlled or uncontrolled, except for when it's a controlled airport, the tower can tell them to do something else. But for uncontrolled, this is standard. Here's one that says right RP here. Okay, there's the information, by the way. Lamar's airport identification, weather is this number, 122.8 again for CTAF, right? But it says right patterns runway 18. So that's the name of that runway. And gonna draw this out here. This is runway 18. So they take off this way, but they turn right instead of left. So they go that way. So they go that way, the base leg, final. So this is downwind. So if somebody says, where is that airplane? If he calls right downwind for runway 18, where is he? Well, he's west of the airport because that's west, and this is east, and this is north, and this is south. South. Okay. So, wow, we're reviewing the heck out of this. Standard traffic patterns are, this is standard again. Oh, here's a controlled airport with right patterns, 2-1. So that's this runway here, right patterns. Wonder why. Grand Canyon National Park, right patterns. Would it be that there's some obstacle or something over here? I'm not sure. But that is a possibility. Sometimes the traffic patterns are set up so that you don't fly over the top of a city. Or there might even be a hill over there. They don't want you to turn on the left-hand pattern because you'd be getting too close to the hill. Or maybe some rich people live on that side of the airport and they don't want you flying over their houses. There's a lot of reasons for doing that. But if it says right patterns, then you turn right. If it doesn't say that, doesn't say anything, it's left-hand patterns. So what's the blue mean? That blue means control tower. How do you find who do you listen to at Grand Canyon National Park? It's a control tower. It says CT right there. 19.10. 19.0 is the frequency that you would listen to see what's going on. Now, of course, you have to stay outside the blue because that's controlled airspace unless you had permission. In general, the concept of Communication is complex. It's not so simple. We have a number of problems with just plain old talking to each other. Even this whole thing on the internet here that I'm doing, I'm talking to you, and the words that are coming out of my mouth sometimes doesn't go into your ears like I mean it to happen, right? There's a lot of psychological and just auditory issues that happen between the sender, the one who's speaking, and the one who's receiving. So sometimes you're the one talking, and then sometimes you're the one receiving, and you have to decode what's being said. There's cultural issues, but there's just the way people talk. And there's bias as well. We have certain mental biases that interfere with communication. Sometimes people do want to be right. Everybody wants to be right. Okay, so sometimes we look for information that confirms what we already believe is true. So we're coming into we're coming into an airport, and for some reason we think everybody's landing on runway 18. So when somebody calls right downwind, but our brain messes with that and is thinking 36. That's something that's just stuck in your head. They're landing the wrong way, but you keep thinking that's not what I think. So we have to be careful we don't have, it's called confirmation bias. It's a common thing that we run into all the time. It's important that we weigh the pros and cons of any idea that we have, that we be willing to accept the fact that we might be wrong. Some people have a hard time accepting that they're wrong. So even if you originally believe one thing, you need to be willing to believe something else. There's another bias that we have is like anchoring. We hear of a fact. We know of some fact. Like, this is the way I've always done it. We live in Griffin. We know that this is what almost everybody's always landing to runway 32. It's the way the prevailing wind is. Everybody's landing that way. So we get stuck on that, and we don't listen to any of the other information. We're not even listening because we just are convinced that this is what's going to happen. Well, it may not. We have optimism bias as well. If we think it's always going to, so we get ready to launch. We never have a problem with birds attacking our drone, so we don't even think about it anymore. But it could happen. We have a bandwagon effect, which is, man, everybody else is flying today. I don't need to check the weather. Well, just because everybody else is doing doesn't necessarily mean it's right. So we have a number of different things, and there's a bunch of other ones. I mean, I'm not a psychologist. I'm not trying to psychoanalyze you. I'm just saying be aware that there are some mental struggles that we have with communication and believing certain things. We have authority bias as well. Sometimes, as an instructor, it's hard. I go out flying and I just assume things, and you all believe everything I say. Well, you should use a little bit of skepticism, because I may not always be right. I'm almost always right. But I'm just saying I might not be. I'd rather you be a little bit skeptical and say, well, yeah, he's pretty smart, but there are some things, he doesn't know everything. I'm fine with that. I would hope, when I was an airline captain, I would hope that my crew felt that way. It's like, yeah, he's pretty smart, but he does make mistakes. He's a human being. We all make mistakes. And I wouldn't want to be the kind of captain or the kind of a crew leader, pilot in command of a UAV crew. I wouldn't want to be the kind of leader that everybody else was afraid to speak up because he's going to get chewed out because I told you that's what we're going to do, and that's what we're going to do. I don't need any more information. I know everything I need to know. Well, who wants to work with somebody like that? Besides it being possible that he might be wrong, or she. So that's our airport operation issue. And yeah, I know at the very end here I dipped into a little bit of human factors, but okay, so look this over and take the test.